So we are back to Studio One. My name is Anton, and on the other side of the table we have Franck, Pachot, who is a developer advocate at MongoDB. And we're gonna have a little debate about the NoSQL databases and maybe something else as well, as the session name refers. Documents, tables, documents in the tables, maybe tables in the documents as well. Let's get going. What are we going to talk about today, Franck?
Yeah, hi. So we will talk about databases and NoSQL versus SQL, maybe some MongoDB versus Postgres, or how to model to do some data modeling. So I'm developer advocate at MongoDB, so I have a lot of enthusiasm for the document model, but I've also 30 years of SQL databases, so I'm biased, but in both ways.
And so you see the benefits and downsides in both now.
Yeah, and I can compare the different state and the different developer experience, because that's what matters at the end. So I don't know if my slides are shared. I guess yes. Okay. So the idea is documents, like in a document database. You have a JSON document, you store that in the database, or normalized table, like we do in SQL databases. We have a different table with a relational model and all normalized. Or what you can do today also is put documents within tables, because in a SQL table you can have a JSON data type on it, and we will look at those three different kind of storage in the databases. To put it more clearly, the idea is tables, relational tables. You usually have multiple tables because it is normalized. For example, if I just want to store some blog posts, I will have a table with the blog post. I will also have multiple tags per blog post, but that will go in another table because it's a one-to-many relationship. Categories may be a many-to-many one. So you have multiple normalized tables. If you model that as document, like in a document database, you will have one document that has all information. If you have put the schema validation, which is not mandatory, but you can just to be sure that you have a schema. And the tags, you just put that as an array in it because you can. And the third solution is document in the table, where you have one SQL table, you put some information in regular columns in the SQL table. But for example, the list of tags, you don't want another table for that. The categories, you don't want additional association table for the many-to-many. So you can just put that in an array, or better in a JSON that can contain an array. So you have some part in a document and some part in the relational one, but less table. So that's the idea from a database point of view. And from the application point of view, the way you access it is different. If you have tables, then you have to map that to your Java objects with object relational mapping, so additional annotations on your objects, so that it can map to those multiple tables. If you have documents, it's easier because it follows the same structure. So you just say it's a document that goes into this collection, and it maps directly. And if you have documents in table, like JSON in table, you declare that with GPA like a table, but you can have a type that is JSON, and where you put an object in it. So different way to access it. It's not only the model, it's also the API that can change. So that was to introduce the idea. We will cover first why I will mention mostly two databases, Postgres and MongoDB. I will debunk some SQL versus NoSQL myths that come from 10 years ago, but all those databases have evolved, and we will talk, of course, about SQL and documents and show some example from an application. And finally, we will see where one makes sense or the other, document tables or documents within the table. So today, it's not really NoSQL versus SQL like it was 10 years ago, because all databases have evolved. You can have transactions in MongoDB, you can have documents in Postgres. And what we see also is that the most popular SQL databases is Postgres for the new workloads, and the most popular NoSQL database is MongoDB. And when I say popularity, there are some companies or websites or marketing who try to put numbers in the popularity, and I don't really trust them because the way it is calculated is a bit wired. But for sure, what we see at customers, users, is, of course, there is a lot of legacy databases, so Oracle DB2, they are still there. But for the new use cases or the applications that are modernized to a new database, what we see is often developers or architects asking, should I go Postgres or should I go MongoDB? So those are the two most popular ones. And if we look at them, so why Postgres for the most popular RDBMS, relational database? One main reason is that it is open source, and a lot of people want to move in the opposite way of what they did with commercial databases, with Oracle or DB2 that are expensive. MySQL is open source, but also belongs to a company. Postgres is open source, but also doesn't belong to a company. So it really presents some freedom. And you have also a lot of companies around it if you need different managed service. So I think Postgres is popular because it gives the freedom for the relational databases, where you can go to one managed service and maybe move to another without changing your application because it's still Postgres compatible. On the document side, on the NoSQL side, MongoDB is the most popular document database, and it's also probably the only NoSQL database that really became general purpose, because you can do document, of course, but with them you can do time series, you can do spatial, you can do vectors. So you can cover multiple use cases, and that's also interesting today. So those two are the popular ones. Of course, there are other databases, and they can also do nearly the same SQL or documents.
I remember 10 years ago, it was like an explosion of different NoSQL databases. Yeah. Yeah, you have it on the slide, Cassandra, Redis, CouchDB.
Yeah, some are still there, but for a specific purpose, not to put all your data for an application.
Mm-hmm.
But yeah, we had also some myth at that time, and I like to debunk them just to start on fresh comparison between the databases. So there is this idea that SQL is too rigid, and NoSQL is more flexible but schema-less. At the end, if you store something without a schema, you cannot do anything with it. So at some point, you have a schema. I've a lot of text in the slides for later reference, but just mentioning that those databases have evolved. You can do some schemaless things in SQL databases because you have many data types that do not need a schema when you write. And in NoSQL, you can also have schema validation. And in all cases, if you need some performance, you need some indexes. And when you need some indexes, you need at least to know the keys that you want to index. So there is a part of the schema that you need to know when you write. Because
we have a comment in the chat saying that after NoSQL, the databases seem to move to the new SQL.
Yeah.
So is new SQL a thing?
Good question. New SQL. The idea of new SQL was to get back to SQL after this popularity of NoSQL and to make them more cloud native. So new SQL was more the old monolithic databases, but with a different storage for the cloud. And part of the Postgres popularity comes from AWS, which started RDS, and then Aurora with a storage that is more cloud native. So that was the new SQL. And then there is the distributed SQL that tries to scale out SQL also. but most of them, NoSQL and distributed SQL, try to be Postgres compatible, because today the NoSQL standard is really Postgres because of the popularity. And something to keep in mind, if you go to NoSQL documents, as I said, it's not really schemaless. If you call it schemaless, be aware that there is always a schema, and to enforce that, I just quote a blog post from Vladimir Schema. You cannot skip data modeling because you go to more flexible schema. You have more flexibility, but you still need some data modeling, and think about how you will query it. And we will come back on that, but that's a big difference between the relational model, where you model your data just looking at the data, not knowing the application that will run on it, where with a document model, you think more about how you will access to your data, and you do a data model that fits the access that you have in the domain. So another myth was that SQL does not scale. But then, as you mentioned, there is new SQL that tries to scale a bit more. And there was also this idea that NoSQL is inconsistent. Today, you have transactions in MongoDB, so you can be fully ACID. You have the choice of the consistency for performance, but you can be fully consistent also. It's kind of tunable consistency. And something also, when we think relational databases, SQL databases, people think about what they have learned at the university about the normal forms, where you have to normalize all your tables. It's always interesting to know the concept. For me, the relational algebra, the normal forms are like math. It's good to know the concept, but then you have to go to real life and understand the reason of it. The reason to normalize is avoid update anomalies, but if you control your update, or if you have static data, it makes sense to denormalize. Understand your data, evolve the data structure because the application evolves. And you can achieve this also with a different normalization than normal forms. Okay, so that was about the different things we have learned in the past about NoSQL and SQL, but today let's talk more about SQL and documents. And again, what we hear from the NoSQL advocates is that SQL is too complex. It can become less complex if you use an ORM like Hibernate to map directly your application objects to the SQL. But then your DBA will complain that it generates a lot of bad queries, maybe. So, yeah, about the complexity of SQL, the way I try to explain it, because if you talk to your SQL DBA, they will tell you that it's not so complex and you have to learn it. And I know SQL, I did that for 30 years, and the way I try to explain that it is complex, take for example the behavior of nulls in SQL. And how it works, when you compare null, when you index null, where you have null in a unique key, in a foreign key, all that. Today, I can pretend that I understand how null works in SQL databases, but to get all those points right, it took me 20 years. So yes, I agree that...
Just before this slide, I thought I know. Now looking at those points, probably not.
Yeah, and that's the problem. If you do only SQL, then you learn it. But if you work with different languages that behave differently and you have to learn that, then it's additional complexity. And also today, so as we started to mention, you can store documents in Postgres, for example, with JSON, but then you have another syntax to learn. And a null in JSON is different from a null in SQL. So you can do JSON in SQL, but then you have additional functions to manipulate that. Compare that with a database that does only JSON, like MongoDB. It's more simple because it doesn't try to combine SQL and NoSQL and JSON and all that. So just, I'm not saying that one is better than the other, but if you think that if you are a DBA and think that the developers are lazy, saying that it's difficult to learn SQL, just look at it from a developer point of view. It can be difficult. Also, the way we interact with the database is very different. In a SQL database, because the idea is that you have multiple tables, because you have normalized, but one SQL statement, one insert, goes only to one table. So if you have a business transaction, it will be one transaction to be atomic, but this transaction will have multiple statements. So here I have an example where I insert the order headers, and then I have inserts to insert the order lines. So the problem is that multiple statements, if you run multiple statements from your Java application, then you have a lot of network round trips. That's not ideal. You can bundle all that in a stored procedure that you deploy in the database. That's what the DBA will tell you. Stop doing so many network calls to my database, just put that in a stored procedure, but maybe difficult to deploy, package part of your business logic.
Could it also depend on the driver implementation? Because some databases allow for batching, if I remember correctly.
It can depend also on the implementation, but then you have to think about how you do it. Also depends on the ORM relational mapping, where you can also have many small queries or one big query, but maybe the one big query will fetch too many data, so you save on network calls, but you have another head. So it's always difficult to map that. SQL was made to process data within the database, like stored procedures. Mm-hmm. But today, we want to put the business logic in a different layer, and then we use SQL as an API between the application and the database, where it was a processing language, not really an API. So compare that with documents. The idea of document databases is that a business transaction is a single document that can have a lot more information, but a single document. If I insert an order, I have all order information there. Just compare that. For document data modeling, I usually tell people, okay, there are some rules, there are some design patterns, but think if you stop the servers and you have to do it on paper. In hospitals, for example, they have the possibility of doing it on paper if electricity is not there. If you do it on paper, you will not have one page with the order header and another page for the order lines. That will be in the single form. And that's the idea of document data modeling. It follows the same design.
So is it true to say that one document should be self-contained without like external references to the other documents, or the real life is different?
Yeah, real life can be different, but ideally one transaction is one document, which means that you may have some data duplication, but ideally this is what we do, and this is what scales. Because if you have a single document, it's quite easy to have it atomic ACID. If you have multiple documents that may go to different servers, when you want to scale out, then it has to manage distributed transaction and has another head. So ideally, it's one document. It can have reference on some static data, but the business transaction itself could be in one document. But that's also a good point. You need to know what will be the business transaction to do document modeling. Where in SQL, you don't really need to, because it's the same schema, whatever you do with it.
Well, somehow in my head, when we talk about documents, I immediately start thinking about some regulations or some government organizations where you come and you fill a document, and then they tell you, okay, you filled this document, now you have to fill 10 other ones. And they somehow need to be linked probably by my personal ID code. But the way I also fill these documents in might be that I fill one document halfway, and then I realize I have to fill the other one, fill the other one, and then continue with the first one. Is this real life scenario is somehow like modeled in
That's a
NoSQL.
good point. You can have multiple documents if they're decoupled. Maybe you can fill one before the other, but you don't have to insert them atomically, and that works. If it's atomic, then it's easier in one document. And there is also physically it's at the same location. Yeah. And when you query, so that was when inserting, but when you query it also ideally in a document database, you query one document and you have all the information that you need, where in a SQL database, you may have multiple queries or one big query with join, and you have this decision. Either you write the SQL query that can be complex with join, or you use an ORM mapping, but then you have to think about the join strategy there. So different way to use it. And another way to show it, just taking some pictures from IKEA catalog. Think about relational databases normalized as they are built for different use cases. For example, you can store the screws in different places, but then to query it and to build something like a chair, you have to build a query and think about it. But it has also an advantage. If you want to build a table instead of a chair, you can use the same database because you have all the components. You just build another query. With document databases, you really put in the database the object that you manipulate in your application or that goes to the user, which is easier to query. But of course, if you do something completely different, tables instead of chairs, then you may need another document for that. So there are those two approaches. And another way to see it, in a relational database, it's like, as I mentioned, different papers. You put the order headers in one place, the order lines in another, and the products in another, and you have a reference. But when you want to get an order, you don't want to go to the different drawers. If you use document, then you have an order that is self-contained at one place, and then physically you can split it differently, like sharding, putting different orders from different regions to avoid latency. So again, it's easier to use, but if you have a completely new use case, for example, if you have a new application that must look only at the products, with the relational model, you have products somewhere. In the document model, you have to go to all of them, so might be more complex, but you can also just have an index on it and you will have them. But that's the idea. Relational databases can serve any application on the data. Document model doesn't mean that you have one database per use case. That would be a nightmare to maintain, but at least per domain. And that's the main point. You normalize when you rent a central database that will be used by all the application in the enterprise, and that's when I started in IT in databases. That's how it was done. You had one central database and all application on that.
And then you learn about left joins, outer joins.
Yeah. So that was working on those databases and still exists today if it's the choice, having a monolithic database. But today, we have better development velocity with domain-driven design where we try to split in bounded context, and then we have a team that can model the documents according to the business entities, and you build a database knowing maybe not all use cases, but the main access patterns for the domain. And then you don't really need to normalize that and bring more complexity, just store the documents as they come in the domain.
Interestingly, we have a comment in the chat exactly about this. It popped up a few minutes ago that in DDD terminology, you would have one document type per aggregate.
Yes. Yeah.
Pretty much.
Yeah. So that's answer the question about references and what to embed. Think about the aggregates. Yeah. Very good remark there. Yeah. So just to show how it can look like with a document modeling. For example, you may have a document per customer with information about the customer, with the shopping cart, and with orders. You don't run 10 years of orders in that. That would be too much, but the recent orders, basically the orders that you want to show when they log in. With such a document, the user log in and you have only one document to get and you have all information that you want to show to them. But if you have a completely different use case, for example, the analysis of the products, then you need another model, because you can put an index on product there, but you have only the recent order. If you want to analyze the order of products for 10 years, then you will probably have another database, more analytic, with a different model per day and per product. So that's the idea of the different domain access patterns. Where if you normalize for SQL database, that's easy. It doesn't depend on the access. You will have a table of product, a table of customers, a table of orders, order lines. But still, there are no really fully normalized databases. For example, you probably store the total amount in the order header because you don't want to look at all the lines and multiply the price quantity and sum them. So that's kind of denormalization. And there is also a kind of denormalization that is really a business requirement. For example, you have the price for the product here. So you don't need the price in the order line because you reference the product. But the price may change. So either you version all the prices of the products, brings more complexity there, or you just put the price at the time of the order. So you may have some duplication in a normalized database, not only for performance, just because the business needs that. And I think I have that in the next slide, but I will cover it here. Another example, if a product name changes. So I'm a customer, I order something, I receive an email with the name of the product. And then 3 months later, you want to change the name of a product, that's okay. But you still want to show me the name of the product the same as what was printed, what was in the email. So it makes sense to duplicate it just because the order was made with a specific name. And I don't want to see on paper something different than on the screen.
Yeah, even in this example, probably related. For instance, in orders table, you have a total amount, which should be the total of order items. Mm-hmm. What happens if the order items change? The price for an order item changes.
Yeah, then you have to maintain it to
like it probably should go somehow event-driven then.
Yeah. But it's more easy today. Even in the database, you can have a trigger that does that. It's not in the relational model. The goal is really to avoid duplication, to avoid anomalies, especially because SQL was also made for end users typing in command line, and then it's easy to forget an update. Today, we automate everything, we test everything. So probably, if you have a use case that changes the price in order lines, then probably you have the code to maintain that. Another thing also I have here, in the document model before, I was storing the shopping cart differently from the other orders, where if it's normalized, it has exactly the same structure. So you can store the shopping cart in the orders table just without a date. On a logical point of view, that works because it's the same structure, but that can be very bad physically because you will fragment your table. You have the shopping cart where people are inserting, deleting. That's different from the orders that you want to archive. So again, in real life, you will probably not normalize at that point, putting all same structure within the same table. So yeah, that's basically the thing. Think about normalization rather than duplication, this idea of the relational database, but think about what you are doing. There is some data that doesn't change. For example, the price at the time of the order. You can duplicate it because it's at the time of the order. It doesn't change. The product name, that may depend on the business rule. If you fix a typo by changing the product name, then maybe it makes sense to see the new name when you query but if it's a completely different name, I don't want to look at the orders and do not recognize what I order. So maybe there are some business rules there that will manage the update. So you need code to maintain that and rules, but can make it easier. Okay, then from an application point of view, that was very database related. So the document model that is very application-centric, how you access to data, and the relational model that is data-centric. And to show the difference from the application point of view, I'm just stealing some work from a colleague, Joe Smith, who has built a Spring Data application with orders and customers. And it did a UI where you can just choose, I want to do it on Postgres or on MongoDB, and it can show the queries that are generated. And of course, it's open source, so you can play with that with different mapping to see the difference, the time, but also the number of queries that matters. So for example, for the same query that was just finding customers and orders, you can see that when you are on Postgres with an object relational mapping like the default in Hibernate, you will have many queries sent to the database, where if the same on MongoDB should be one single document there. And so he did this application that you can run, but also he did good documentation on it, showing the two data models. When it's normalized, you have order lines, you have orders, the email is in another table, the address is in another table, and the address may be referenced by the customer, but also the order if it has a shipping address. Where when you do documents, you have less collections with more information in it that can be embedded. So that's quite small, but you can go see it. Basically, I have addresses at different places. But that's not a big problem. In the relational data model, when you have an address, you normalize it, even if it's just an information, because it's just the way data is normalized. In a document model, if the address is just an information, just put that, and you can even put that in a text. Of course, if it's not an order entry application, but an application at the post office or the city hall, then probably the address will be more structured. It really depends on the domain. And for the code, we see the difference on a relational database. Then we have this mapping to do, and also some tuning to do on it. Do I want to avoid too many round trip and read by batch? And do I want to read everything, every object related to it, at the risk of reading too much, but reducing the round trip? So you have this choice to do when you do the object relational mapping, where with a document, you already did this choice when you design the document. So you just map the document to the Java objects easily. And for the transaction, the same as what we have seen. So with the same application, if you look at the transaction, you see a lot of SQL statement when you are on a SQL database, because there are many tables, where an insert, for example, is a single document that has everything in it. Probably it's larger, it has more information, but today that's not a big deal. Reducing the round trips is good, and also having a self-contained document makes it easier when you distribute, because it's at a single place. Distributed databases are always complex, but it's much simpler if finally the transaction goes to a single shard. What's complex when you try to scale out a database is when you have a transaction that has to touch the email table that is in a specific node and the customer table in another one, and then you want to be sure that this will happen atomically at the same time, even on nodes which do not have the same clock. So when you query it also, either you use ORM, generating many queries as we have seen. You can also write SQL, and that's totally okay. The problem with that is that the SQL will become more and more complex, and when the application evolves, you will add more tables, and then you have more SQL queries. So usually the advantage of Hibernate ORM is that you avoid this increasing complexity in number of queries that you have to manage. But also something important from a performance point of view, this query joins many tables, and in the where clause I have selective filters on multiple tables. But in a SQL database, you can index only one table. So if you have different selective filters on different tables, the optimizer, the query planner, will have to start with one. And maybe we'll read more, do joins to filter later. Where if everything is in a single place, a single document, you can have an index that will cover all the filters. So it will be more performant, not because it's doing less joins, but because it can filter, it can avoid reading too many rows, joining them and filter later. So if you want to try this application from my colleague and look at the queries generated.
Let's keep this slide for just a few seconds more. And meanwhile, maybe a little bit unrelated question to the whole presentation of ours, because you mentioned the number of queries multiple times and the n+1 query problem. So we have one query and then we have multiple follow-up queries depending on the result of the first one. Is it always a problem?
Multiple round trips to the database, I think is always a problem because this n+1, the n depends on the size of data. So if data increase, this n will increase. It's network, but today, if it's not too far, it can be fast. But more than network, it's also context switches in the database and in the application. At some point, when you do a network call, your process leaves the CPU so that the server can give the CPU to someone else. And this switch of context has a cost, and a cost in CPU also. So I've seen that when you want to advocate for stored procedures, doing everything in the database, and I know that it's difficult from a developer point of view, but from a performance point of view, there are some people who think that doing less in the database will save some resources, and especially in NoSQL or expensive databases licensed on CPU, you want to save CPU. But then you realize that putting more on the database saves CPU, because even if you do more, you have less context switches, and then finally you save on that.
Because of the different round trips.
Yeah.
Okay.
So ideally, one transaction should be only one network round trip. But the problem is that when you have the logic in the application, you don't know in advance what you will have to read. So that's the idea. If you write the full SQL dedicated to the use case, you know exactly what you have to read and you can do it once. But if you have a mapping that is used by multiple use cases, it's only doing the code that you know that you will need more information.
Right. I guess as always, the answer to this is it depends. Because sometimes doing a lot of small queries will perform faster than a big join. So it's dependent on the data, on how the data is indexed.
Yeah. And also do not do too much premature optimization. There are a lot of small use cases where you don't really care if you do multiple round trips. Put the focus on the critical use cases.
I see. All right.
Okay, then talking about documents and SQL, looks like you have only two choices, but you can also put JSON in a SQL database, and there are even some people who think that, I've seen that on Reddit multiple times, like, just put a primary key, UID, and JSON in Postgres, and then you have a document database, but it doesn't work like this. But first, JSON in SQL databases, it's not so new. I've been working with different RDBMS for a long time, and I've always seen arrays, objects, nested table, whatever way we call it. XML was
XML
at some point.
Was the thing.
And, so yeah, today JSON is quite nice because it's easy to parse by the application, also easy to read, but also we put vectors today, so putting more than atomic data types in a database, that's not new, already exists for a long time. Also here I have a link. If you look at the original concept of Postgres, so that's 25 years ago, the idea was really to be able to store complex data type. For example, Postgres has had spatial data for a long time, so vectors was 2 or 3 dimension vectors. Today we put 1,000, but it was the same idea. And however, the problem is if you want to use Postgres as a document database and putting everything in JSON fields, then you will have a problem not in storing it, but indexing for it. In a document database like MongoDB, it is made to access and index documents. So you can have an index that covers fields that may be nested in sub-objects or even arrays. Where in Postgres, you have 2 different types of index. Either you index a scalar value with a bit-tree index and you have a lot of possibilities, or you index something that is under an array, like any information under the order lines, like the price or the product. But then you need to use an inverted index, GIN, and it's useful for some kind of searches, but not for something else. For example, it cannot be used for range queries. I cannot query the order items for a range of price, for example, there. And also, what is in JSON is a black box for the optimizer, for the query planner. It doesn't have statistics like in columns. So what I'm trying to say here is that it's very good to have JSON in Postgres, and it's good to have more flexibility, but the idea is not to put everything in a JSON object, because you can do it, but you will suffer from many problems.
I have a stupid question here. Yeah. So if we create an index on a column where we store the JSON, it sounds kind of logical to have an index on one attribute. Can such indexes support multiple attributes? Let's say one attribute on the top level, the other one on a nested one, and have them like a compound indexes?
That's the problem. You can in Postgres with an extension, so having a GIN index that has additional other columns, but it doesn't have all the possibilities of indexes. Usually indexes, you use them for equality predicates, so most indexes can be used with that, but also to find a range of value, or also to sort. Indexes are very useful in OLTP applications for pagination queries. I ran the last 10 orders ordering this specific product. So if the product is in the array of order lines, I want to have it in the index, but I want also the order date. And I want to use it. What I want to avoid is reading all the orders for a product and then sorting them just to get the 10 ones. So I want an index that gives the entries in a specific order. And in Postgres, you can do that only if it's not under an array, just with regular indexes.
I see.
So that's a big difference, where in MongoDB, for example, you can have an index that serves some equality. There is a page in the documentation that is equality sort range to recommend the best index that you can do. You put all your equality fields in front, and then the sort, and then range.
I see. The reason I ask this, because if it is possible, then what is the point of storing JSON in a relation database, because it kind of seems that we are putting the JSON in, but somewhere inside the database we are creating the other different schema for it, like in the form of indexes. So,
but some part of it, for example, I would not put the product name and price in a JSON in a relational database, but the customer address. Except if you want to query by zip code, for example, and you don't want to query on. If you want to query on a range of zip codes, then you will have a problem. But that's probably, if you go to a document modeling, then you are within a domain, and in your domain, if you want such queries like products by zip code, then that's probably more an analytic one rather than OLTP.
I see. Address modeling is surprisingly complicated task, like depending on the country, location, cultural differences.
Yeah, ideally you try to normalize, but Satya Nadella said something recently like the world is too complex for SQL. And that's exactly that. On a paper, you can start like thinking, okay, an address, it's a number, a street, a zip code, and a country. And then you look at real life and you see that some cities are renamed, that you have some numbers where you have a A, a B, or whatever. And
in some countries, they don't have numbers for buildings. They only have names or...
I've been working on a banking application that was a long time ago. It was an application made in France, and then we implemented in Africa. And we had to change, there were a lookup screen to find the customer. And in France, you just entered the date of birth. But in Africa, people know that they are born between this date and this date. So those are the different things where you have to adapt, because the world is a bit more complex than this structure. And the problem, you can model everything in a relational database. But the problem is that you will have to adapt the whole structure for the exceptions. Another example, for example, I've been working on for an airline company, and usually you think that an airport is related to a city and to a country and all that. And I think there is only one airport that belongs to two cities. In Basel, it's Basel-Mulhouse. You have an airport that belongs to France and Switzerland and to multiple cities. So your one too many becomes a many too many, but for a single object. You have to change the whole schema. Where with a document model, you can have documents with a scalar value and documents with an array there. So more flexibility. So finally in the different choices, if you go documents, so I recommend to go to a document database, not try to use Postgres as a document database. You can store documents, but not just an ID and the document. And mostly because of the indexing possibilities. You can go on relational table if you really want to have a data model that is independent on the application. But think about the fact that each index is single table, so you will have a problem when you have selective filtering on multiple tables, and then you may have to denormalize there. And you can have also tables with JSON in it, but think about the indexing possibilities. Usually, if you have a field, if you put things in JSON and you have a field that will be updated, for example, a counter, put it as a specific colon. You don't want to rewrite the whole JSON document in Postgres just because you updated one value. And if you have indexes on them, there is a good chance that it will be better as colons. And then other information, like, for example, the blog tags or the address, then if it's not the core of the domain for your application, that's okay to put it in a more flexible schema.
There's a good question in the chat. It might be answered in your some of your upcoming slides, but nevertheless, Pascal is asking, do you recommend duplicating integrity checks in Java code, meaning the application code, duplicating the constraints put in the database?
That's a really good question. I would say yes, if it was easy. The big advantage is that, of course, you want to check it before reaching the database because you don't want to send junk to the database just to realize that it cannot fit there. But you want also to enforce it in the database. First, because it can happen that you update something manually in the database to fix a hard bug, and the constraint will save you from many problems. Also, integrity constraints in the database are used by the optimizer. If the optimizer knows that your char colon can be only yes or no, it may take a different decision when estimating the selectivity of a query, for example. So yes, it's good. The problem is that then you have multiple codes because usually you have different languages. So there are some databases, for example, in Postgres, you can have extensions with different languages and you can put some JavaScript. Oracle has also introduced a GraalVM in the database to be able to take libraries, not to have duplicate code. But yeah, ideally, yes, but think about the duplication of the code, yeah.
I see.
And yeah, on the indexing, just to compare, when I say some indexes are difficult if you are not if you are on a document and not in a document database, can be as simple as what I mentioned, looking at the orders for a specific product and ordered by date. And I also tested that there are many MongoDB compatible layers on top of SQL databases. For example, in AWS, DocumentDB, it's not official, but it runs on a Postgres database. Cosmos DB at Microsoft works also with an extension on Postgres. So you find a lot of compatible API in many databases, but I tested just this simple query. Can it use this index? And only MongoDB can use it, because in the storage, it is built for documents. Doesn't mean that you cannot use them, but be aware you don't have the same indexing possibility. So maybe you can start with them and move when you have some performance reason to do better. And yeah, there are many questions about which database to use, because I mentioned the two, but just to summarize, if you build a normalized model for a central database for many applications and you don't know those applications yet, then nothing is better than a normalized model if you do not know anything about the access pattern. Because you need to normalize for that. But then be careful, you need to write SQL code or do good ORM mapping. If you are in a domain where you know not all use cases, but the main access pattern of it, then you can use a document model and it will be simpler because you don't have this mapping, you don't have complex queries, and usually simplicity is always good. It make you evolve faster on the application. And also, a lot of people are asking which database is faster, which one scales the best. So avoid the problem like I mentioned. If you use Postgres just with a UID and JSON-B, then it's probably not a good idea. But also, if you use MongoDB like a relational database with too many references, you will have also problems. So use the database in a good way, and the fastest database, the best database, is the one where you do correct design and the correct application. If you know only one database and not the other, and this one database is not the best but is good enough, you will be more successful with the one that you know.
I have another stupid question here, since you mentioned references. So if I'm querying a document that has a reference to another document, will this reference be resolved automatically, or I have to do that on the application level?
So if you do that on the application level, then you will have multiple round trips. So if it's in MongoDB, you will use an aggregation pipeline with a lookup. So in one query will declare all the stages, and the stages can be read from this collection, filter on that, look up on other collections, group, aggregate, whatever. If it's JSON in Postgres, you can also do that with all the JSON function in SQL. So you have to code for it if you use documents, because the schema, you have no foreign keys, you have no declaration of this reference in the database, but you have it in the application. So the application either does it or generates how to do it. And that's also can be the ORM mapping that. Yeah.
So either way, you will have the code, but the difference is where the code will run.
Yeah, but also in a relational database with a normalized schema, you will code the join, but you will just declare the join, and you let the database decide in which way it does it, which is good because you don't have to think about it, except if there is a problem, then you have to look at the execution plan, understand how it works, and all that.
Oh, there is a good technical comment that if the pipeline hits 16 megabytes, apparently it's a limit, hard stop limit for...
Yeah, in MongoDB, the 16 megabytes is not even the limit for a document, is the limit for JSON, and what is exchanged with the database is a JSON. I think you can fetch it in multiple times, but yeah, the idea of aggregation is to aggregate.
Getting a something like JSON is a binary.
Yeah, it's a JSON thing. Yeah.
Getting 16 megabytes sounds like a big document.
Yeah. If you reach that, then probably you have something to do differently. For example, if you do an aggregation pipeline to show something on the screen, that probably fits. If your goal is to generate a big report to send a file, then you will probably do it differently. The aggregation pipeline may put the result in a collection, and then you will fetch the collection also because you will fetch in multiple batches, and if it fails, then you can fetch it later. So yeah, never reach this JSON limit, either to store, either for the result. And that comes to the storage internals. It's good when you use a database, it's good to understand how it works from an API point of view, but also how it stores data, how it indexes data. I will not go into the detail, but also when we say Postgres, there are multiple Postgres. All managed services are forks of Postgres, which may change very little things for security reasons or more things for performance or distribution reasons. So it's good to understand how it works. And something important also there, I mentioned that in a relational database, the database knows the schema, where in a document database, the application knows the schema. So if the application manages the schema, then you need more code, but it makes it easier to upgrade the database because the database can just upgrade the nodes without caring about this single point of truth that is the catalog or the schema. And and finally, the question is often, what is the best database? The best database is the one that you know the best. So of course, if you, as I'm developer advocate for MongoDB, I will recommend MongoDB, but if you don't know it, I will first recommend you some training content. Don't use a database that you don't know and just guess that it's flexible, you don't need a schema, whatever, you need some design. And and think about simplicity. Do things simple. You can do very complex thing, very complex schema, but it's always more difficult to evolve on that.
Right. So can we summarize that if you're just starting out, it's better start with relational, and as you see the access patterns, we probably can adopt document?
That's a good question. I think it's good to learn the theory and the relational databases, but also depend if you have time for that. When I started in databases, I did only SQL, so it's easy to learn something and be expert if it's the only one. But if you are full stack developer, take the simpler API maybe. Yeah.
I see. Well, that's the time over for us. Great session. Thank you.
Thank you.
Franck.